Math Simplified for 9th Standard, Area of Triangles and Quadrilaterals, Exercise 7.1, Question 5 to 10. We are studying the 7th chapter, Mensuration, and we have done the first 5 sums of Exercise 7.1 in the previous video. Please go through that video and then come to this exercise, because there I have explained in detail how to use Heron's formula. Okay, so here also we are going to use Heron's formula to find the area of triangles. So let's go to the sum. Question 6. Find the area of unshaded region. Angle BDA is 90 degrees given. Okay, so here is the figure. These are the values they have given us. This region is actually unshaded here. You know, this, can you see the pointer? This region. So they're asking us to find the area of this region. Okay, so here you can see from the figure that there are two triangles. One is triangle ADB, the small triangle. And there is another triangle ACB, the big triangle. So if you subtract the small triangle from the big triangle, we will get the area of the unshaded region, this region. Is it not? So big triangle minus the small triangle. So we have to find the area of two triangles here. And we are going to use Heron's formula. Okay. So here, first of all, you can see that we need all three sides for Heron's formula. So here, let's take the small triangle. We do not know this side. Okay. But they have told us that this angle is 90 degrees. So it's given 90 degrees. So this is the hypotenuse. So we are going to apply Pythagoras theorem and first find this length. So AB square is equal to DB square plus DA square is equal to 16 square plus 12 square. So 16 square is 256, 12 square is 144. Add it, you get 400. AB square is 400, so AB is 20 centimeter. So we found this length of this side. It is 20 centimeter. Okay, now let's take this small triangle and apply Heron's formula to find the area of this triangle. It is equal to square root of S into S minus A, S minus B, S minus C. A, B, C are the sides of this triangle. So let us take side A as 20, B as 16, C as 12. 20, 16 and 12, ABC. Now let us find out S, which is the semi-perimeter. That means we have to add the three sides, divide by 2. So add it and divide by 2, you'll get 24. So you got A, B, C and S. Now we are going to substitute in Heron's formula here and get the area. So let's find out S minus A, S minus B, S minus C. S is 24, 24 minus 20 is 4, 24 minus 16 is 8, 24 minus 12 is 12. So you got these values. So let's find out this S into S minus A, S minus B, S minus C. 24 into 4 into 8 into 12. That is equal to 96 into 96. This is the square form. I'm writing it so that it's easy to find the square root. So square root of 96 square is 96 square centimeter. So we found the area of the small triangle ADB. Now we are going to find the area of this big triangle ABC, and then we will subtract this area from the big triangle area to get the area of this region, unshaded region. Okay, now let's go to the big triangle ABC. Here the sides are 42, 34 and 20. A is 20, B is 34 and C is 42. Find out S, add and divide by 2, you get 48. Find out these values, S minus A, S minus B, S minus C. Find out this expression, write it in square form like this, and then do the square root, you will get the area. So 4 into 14 into 6 is equal to 336 square centimeter. That is the area. If you want, you can even multiply and then do the square root. Doesn't matter, whatever method your teacher teaches you, you can follow it. Only you have to simplify this expression properly. Okay. Then the area of unshaded is area of triangle ABC minus area of triangle ADB. 336 minus 96, which we found before, is equal to 240 square centimeter is the answer. Question 7. Find the area of quadrilateral ABCD whose sides are AB is equal to 13, BC is 12, CD is 9, AD is 14, diagonal BD is 15 centimeter. So here is this quadrilateral. They've given all the sides. So now it's easy. They're asking us to find the area of the quadrilateral. That means first we will find the area of this triangle ADB, then the area of BCD, this triangle. Add both the areas, you will get the area of the quadrilateral ABCD. So here, let's use Heron's formula. Let's take ABD, this triangle first. So A is 13, B is 15, C is 14 here. So S is equal to 13 plus 15 plus 14 divided by 2. That is 42 divided by 2. That is 21. S is 21. Let's find out S minus A. That is 21 minus 13 is 8. 21 minus 15 is 6. 21 minus 14 is 7. Okay. Then evaluate this expression. Write it in square form. So the area will be square root of 7 square into 3 square into 4 square. This is equal to 7 into 3 into 4. That is 84 square centimeter. See here, this expression, I have just factorized 21. 7 into 3. Okay, left 8 as it is. 6 I have written it as 3 into 2 and 7. So you get 7 square, you get 3 square. Now 8 into 2 is 16. 16 is 4 square. So 7 square, 3 square and 4 square. This is how I have written in the square form. So it's easy to find the square root. 7 into 3 into 4, 84 square centimeter. So now we found this area of this triangle. Let us find the area of triangle BCD. So again, take this. Here the A value will be 12, B is 9, C is 15. You can take any values. It doesn't matter. You can even say A is 9, B is 15, C is 12. Doesn't matter which order you want to take. You will anyway get the answer. Okay. Then find the value of S. A plus B plus C upon 2. You get 18. Evaluate all these values. Write it in the square form. Then you will get the square root easily. It is 9 into 6, 54. Now the area of the total quadrilateral will be this area plus this area. So 84 plus 54 is equal to 138 square centimeter. A park is in the shape of quadrilateral. The sides of the park are 15 meters, 20 meters, 26 meters and 17 meters, and the angle between the first two sides is a right angle. Find the area of the park. So here this is the figure of that park. This angle is 90 degree. They have given us the length of the sides of the park. 15, 17, 26, 20. Okay, now we have to find the area of this park. Simple. Again, first find the area of this triangle, then this triangle, and add both the triangles. This angle is 90 degree. So we know that area of this triangle, we can easily find it is equal to 1/2 base into height. This is another formula for area of a triangle. So here it is 1/2 base into height. So 1/2 15 into 20. 15 into 20 is 300. 300 divided by 2 is 150. Okay. Now we are going to find this length, because for this triangle we have to use Heron's formula only. Okay. So for this length, this is the hypotenuse of this triangle. So dB square is equal to 20 square plus 15 square. Okay. So that is dB square is equal to 625. Therefore dB, this length is 25. 625 square root is 25. Okay. Now let us take this triangle DBC. We know this value 25, 26, 17. So A is 25, B is 17, 6 is 26. Okay. Find out S. Add these three values, divide by 2. S is 34. Okay. Then you just have to simplify for the Heron's formula. Write down all these values, write it in the square form like this, and then find the square root. You will get this answer. 17 into 4 into 3, that is 204 square meters. So area of the quadrilateral ABCD is equal to 150 plus 204, that is 354 square meter. A land is in the shape of rhombus. The perimeter of the land is 160 meters and one of the diagonal is 48 meters. Find the area of the land. Okay, so here we know this is the figure of a rhombus. All the four sides of the rhombus are equal. Okay, so here it is. And they've given the perimeter as 160. So what it means is 40 plus 40 plus 40 plus 40 will give us 160. That is, the length A of each side will be 40. Is it not? 160 divided by 4 will be the length of each side. Diagonal is 48. Okay, now let us take the triangle ABC. Let us take this triangle. Okay, and then, so these two sides 40, 40 and this length AC is 48. So here you can take, find out S, 40 plus 40 plus 48 divided by 2, that is 64. Then find out these values and find the area of this triangle ABC. It is 768 square meters. Now the area of the rhombus is 2 times this value because both these triangles are equal triangles. So 2 into 768 is 1536 square meters. The adjacent sides of parallelogram measure 34 meter, 20 meter and the measure of the diagonal is 42 meter. Find the area of the parallelogram. So here this is a parallelogram. The values of the sides are given. Diagonal is 42. Both these triangles are equal. So in this sum also, if you find the area of this triangle, multiply it by 2, you will get the area of the parallelogram. So let us find the area of triangle ABC. So here A is 34, B is 20, C is 42, S is A plus B plus C upon 2, 34 plus 20 plus 42 upon 2, that is 48. Find out these values, S minus A, S minus B, S minus C. Substitute and then evaluate, factorize in such a way you get squares like this. You will get the answer as 336 square meter. You have to multiply this by 2. So 2 into 336 is equal to 672 square meter is the area of the parallelogram.